Okay, I think we are getting started now. So, good afternoon, everyone. Welcome to the latest webinar in the CCP Volume EM Show and Tell series. Thank you very much for joining us today. For those of you who don't know me, my name is Helen Spiers, and I've been co-hosting this series with Martin Jones, who is PI of CCP Volume EM, and he is co-host on this call as well. So today I'm delighted to introduce our speaker, Dr. Cameron Shand from the Francis Crick Institute, who will be presenting today on AI OnDemand, an extendable user-friendly framework for segmenting images at scale. So Cameron is a senior machine learning engineer within the software engineering and AI science technology platform at the Crick, where he works with research groups to develop and apply AI tools that help accelerate biomedical research. So during today's talk, Cameron will introduce the AI on-demand framework, demonstrate some of the different ways it can be used, and explain how it can support researchers across different institutions. We'll also hear about how members of the community, from non-computational microscopists to AI model developers, can benefit from and contribute to its development. So just to note, we are recording this webinar today, and we will likely share the video on the CCP Volume EM YouTube channel, so you will be able to catch up there. There will be some time for discussion at the end of today's talk, so if you have questions during the webinar, please add them to the Q&A tab. And with that, it's my pleasure to hand over to Cameron. Welcome, Cameron, and thank you for joining us.
Thank you. Okay. Just share screen. There you go. Okay, so yeah, thank you for the introduction. So I'm Cameron Shand, and yeah, I'll be talking about AI on demand. So it's sort of no surprise really that sort of AI is being used in a sort of ever increasing number of applications, sort of within imaging, but sort of in general for sort of accelerating research. And although the tooling keeps improving for sort of using these models, there's still a lot of challenges with trying to use them, particularly when sort of trying to use them at scale. And especially when sort of the data sizes just sort of keep increasing. So, now what previously is producing gigabytes of data, sort of regularly moving towards sort of terabytes, in the future going to sort of petabytes of data here, as sort of kind of shown by the famous sort of H1 data set there on the side. And with this, there's a lot of challenges and further complexity that's inherent to the size of that data. And as well, when you're working at the cutting edge of sort of data generation, looking at sort of organelles or image modalities or just sort of the actual cells and models that are in question, many AI models need sort of fine-tuning or some kind of prompting to actually do well on sort of this novel data. And so this is really the sort of like the generalization gap when trying to work at such a cutting edge. Using some of these models, there's really different pains for different user groups. So I've tried to sort of categorize a few different sort of user groups based on sort of what I see, at least in the context that I work at the Crick, and sort of different levels of sort of knowledge as well inherent in that. So you've got your sort of scientists and microscopists, the sort of more sort of wet lab, non-computational people, sort of machine learning practitioners who have a bit more sort of familiarity, and then your actual sort of model developers, so people that are sort of training AI models and actually sort of creating the things to solve some of these problems. And then a few different sort of categories of areas of trying to use these models. So when it comes to sort of trying to run these models locally, for our first sort of category, this can be okay or sometimes painful, but it really depends on sort of the model authors. So sometimes you have sort of very nice documentation or they're very easy to install, so then it's sort of less painful to do. So it might be okay. For our ML practitioners with a bit more experience, generally they can navigate some sort of typical installation issues, so it's generally okay. And then on the model developers, they should be pretty familiar with navigating these problems and even probably have some opinion on sort of best practice and that kind of thing. When trying to run these models on HPC, so our high performance compute clusters that sort of your institute may have, or instead sort of running things on the cloud, either way, some sort of bigger separate sort of compute cluster to use. Running these models can be quite painful. And even in the case of if someone has already done it before, it can still be quite painful. Surprisingly, it, what works for one person doesn't always work for everyone. For our ML practitioners, that little more familiarity can help, but this is slightly dependent on sort of the HPC and the setup. Sometimes people don't have a lot of control with what they can install, and so things can still be a little bit painful there. For our model developers, they have generally navigated the sort of intricacies and individual issues of their specific institute's HPC, and so they can usually get these things running, but maybe not necessarily at scale or sort of running them efficiently. Are they really utilizing the full compute of the cluster? Not always. When it comes to fine-tuning models, so this is then actually trying to sort of address that generalization gap. So customizing a pre-existing model to do better on your specific data. That's what I mean by fine-tuning. Some models with their documentation, they'll have a guide on how to do the fine-tuning, which can really sort of simplify things. There can still be sort of the other issues around installation and that kind of thing. But if there isn't a guide, then I think for generally, at least in my experience for our sort of scientist category, it's really a non-starter. It will take way too much time to do these things that it's just not worth it. For our practitioners, if there isn't a guide, then maybe they can sort of navigate the code base and pull out the information that they need to actually do the fine-tuning that they need to do if there's no sort of machinery in place, at least. For our model developers who are more experienced with this, they should be generally okay with sort of doing some of the fine-tuning. Again, there's sort of questions around how efficiently they're doing this across sort of multiple GPUs and things like that, but it's a bit more possible. Now, if we're looking at then sort of the ability to do all of this in a sort of very reproducible way, um, I think so if we define sort of a high bar of reproducibility, sort of using containers and really having full like traceability of what it is that you've done, and then the knowledge and ability to know that several years from now you'll be able to exactly recreate everything that you've done, then I think on the microscopist level, there's not a lot of tooling usually in place inherently. So if you just get some sort of code base on the internet for a model, there's not really the surrounding machinery to really help with that reproducibility. Beyond maybe sort of ad hoc ways of seeing that I do, which is that I've seen of just having sort of, Word documents to like document the process of these are the things that you need to do. But that doesn't necessarily extend sort of years down the line. For our practitioners, there's still not a lot of the machinery in place. They're not necessarily familiar with containers and things like that, so the reproducibility can still end up being low. And I think this extends even sort of to the developer. You can be incredibly familiar with sort of training AI models and things on the sort of the research side of things within AI, but you still don't necessarily know about setting up containers and doing things at that level of reproducibility. There is also another group of people here. So the actual people that run the high performance compute, and they encounter issues from the other side of people trying to use these sort of AI models and these different frameworks. Things I've heard along the endless creation of many Conda environments can cause issues. Lots of times, people are running jobs that are incorrectly specified. So they're requesting maybe more memory than they need or more time than they need. Sort of submitting a job that requesting 2 days when it only takes 2 hours. Or maybe requesting multiple GPUs but only really using one. These are sort of fairly common issues. And when we're looking as well, some people those are using legacy software, then we end up in situations where versions are no longer supported. So there's a lot of issues that can then occur with that, particularly when people are using sort of older models that academics may have sort of created and then sort of not maintained or kept up to date. So they're using sort of versions of Python or other packages that are now no longer sort of secure or can really be used. And they don't necessarily have the ability to update those things either. So AI OnDemand was sort of designed to try and address some of these pain points and to be useful for these different user groups. And so we have a few sort of overarching aims for this. And the first is to reduce the barrier to entry and reduce really the frustrations in using these AI models. And to do this in a way that's agnostic to the compute environment. So whether you're running things on your laptop, running it on the cloud, or running it on your institute's HPC, we really wanted something that can be agnostic to that, so that can be ported across them. And this also extends to being something that's portable across institutions. There's no reason why something should only really work in one place. We wanted to create a platform that we could easily extend, both us and the community. So things like adding more models, adding more interfaces, changing and adding different processing steps. We wanted to have something of where different people could customize and add different bits into this to make it extendable and therefore just increase the functionality and the utility for everyone. And we really wanted to enable non-experts in particular to be able to sort of customize or fine-tune the models for their own data. Because again, when you're working at that cutting edge of sort of new image modalities, there's not going to be models off the shelf that work well enough for your actual data. So the ability for people to customize that without necessarily knowing or being able to do everything underneath is really important. And then across all of these aims, we really wanted this to be achieved with a focus on reproducibility, as I mentioned, and really accessibility, but without the loss of customization. So that if we have someone who's more of an expert user who really wants to go in and sort of customize specific model hyperparameters and this kind of thing, that they can do that. But this is not at the cost of accessibility, where you're overwhelmed with sort of 100 options, but it's things that should be able to be edited if desired. But yeah, those are the overarching aims for AI on Demand. And this is a sort of overview schematic of exactly what it is. So the key thing here really is that we have a separation between the front end. So this is on the left, the actual, the user interface, the things that people are generally familiar with using, but then a separation between that and then the back end, which is where the actual sort of computation happens. So this is where then the model gets run. Oops. And so this is a case where having this separation gives us a lot of different sort of benefits and features, which I'll go over sort of throughout this talk. To give some sort of illustration of the front end, AI on Demand is meant to be completely agnostic to this so that it can kind of fit existing workflows and how people generally go about doing sort of image analysis type things anyway. So the first category of sort of software is our image viewers. So things like Napari, QPath, Fiji. But it's also useful to maybe have a front end that's just a sort of a web app, some URL that you can go to and then use that to sort of configure the pipeline, or even just having something sort of a complete GUI or graphical user interface that's sort of standalone that can then exist outside of all of these things, which is very useful from a sort of portability perspective. These are the range of options. At the moment, we have created a Napari plugin to go with sort of AI on Demand. This is mainly because sort of researchers at the Crick were sort of already using Napari, and to be honest, it's quite an easy thing to develop plugins for. So it was our sort of first port of call. But other front ends for other software could exist too. And then on the back end side, this is really then just you have some sort of configuration that then defines all of the important things for AI on Demand, like the model, the parameters, some different steps, and then what data you're running on. And then we have this Nextflow pipeline that's then actually doing all of the computation. So what is Nextflow and why do we use it? So it's a workflow system for writing computational pipelines. And one of the really useful things that kind of automatically achieves one of our aims is that it simplifies the deployment and the scaling on sort of HPC. It can be run locally. It can also be run on cloud, as you can see on the right in the diagram. It can be used in a lot of diverse compute environments. So it gives us a lot of the things that we're looking for free. And it also has some really nice sort of features and benefits like dynamic resource requests, which I'll go into in a bit more detail later. But basically, it means that the actual resources that your jobs are requesting, whether it's sort of time, memory, or anything like that, can be scaled to your actual, let's say, the size of the input data and things like that. So we can be a bit more efficient with our compute. We also sort of improve the reproducibility because Nextflow, you can define process-specific containers or environments so that each process or each model can then sort of be really scoped and just defined in its own environment, which is very useful if you've got multiple models like we have on AI on Demand that have very conflicting requirements sometimes. Nextflow also creates a unique folder for every process, and that unique folder is defined by what we call a hash, which is just a sort of unique string of letters and numbers, and that itself is defined by the input parameters. So this means if the input parameters are the same, so you're running the same model with the same parameters on the same data, then that the folder, if it's already been created, we can then reload and reuse those results. Again, sort of more efficient compute, very useful. So I said Nextflow is a system for writing a computational pipeline. Computational pipeline might not mean an awful lot either. So I'll give like a sort of brief overview of this is that in Nextflow, we can define processes. So processes should be reasonably atomic in what they do. So it could either be at the level of we have a process for pre-processing an image, or we could go a little more granular and say we have a process for just doing denoising on an image. Something like that. But either way, these are fairly sort of independent specific processes, and then we define a workflow that then stitches these processes together in a way that we control. So in this case, we've just said we've got 4 processes and then we run them in sequence, such that the output of process 1 is then being used as the input to process 2. So we get this chained pipeline. But on the workflow side of things, we can also make some modifications to different outputs. So we might do some filtering, maybe some sort of like quality control. So we're adjusting the inputs that are then for the future processes, which can be sort of very useful. But we can also define different workflows that maybe just skip processes that may not be relevant to a particular kind of processing that we're doing. Obviously, we can also have process outputs from processes be inputs to future processes. This can be then quite useful to then have better use of sort of parallelization as processes run as greedily as possible. So a process cannot run until its input is available. So through this of chaining, you can do some quite interesting things, and we can make that a little more complex even by having some sort of dynamic processes. So in this case, let's say the output from process 1 is when the value is above 5, we actually run an alternative set of processes in the middle. So here we can create some very useful, interesting dynamic pipelines that, again, as sort of pipeline authors like myself, we can do this to create some sort of sophisticated functionality without the users necessarily needing to know what's actually happening underneath. So that's kind of what a computational pipeline is, and in general, sort of why Nextflow has been so useful for us. But yeah, that's going back to the overview of AI on Demand. We've got the front end and then the back end of this. And if all things sort of work well, then our Nextflow backend sort of produces the results, and then those results just get loaded back into the interface that you're seeing. So from a user perspective, it should be a very seamless thing that jobs get submitted on your behalf, the computation happens, and then the results just appear at some later point in time. So AI on Demand at the moment is structured into sort of 5 different GitHub repositories. So we've got that Napari plugin front end that I mentioned, the Nextflow pipeline backend, but then we've also got a separate package for our sort of model registry, which is where the models are defined, and then some utilities and documentation. And this has some sort of advantages. So on the Napari side, we've got our accessible interface that does everything for you, that then creates the configuration and runs the Nextflow pipeline on your behalf. By having the model registry as a sort of separate repository, in this registry, we have sort of a schema, which is basically just the definition of the model and some other things about it, which I'll go into later. And having this as a separate repository means we can set up some automatic validation on it. And it also means that it's a central source of truth. So the information about the models can be served to our front-end interfaces and our back-end pipeline. And so if anything about the models changes, there's just one place where that change happens, and then it's distributed across everything else, sort of live as needed. Our separate utilities package does a similar thing, but by standardizing the way that, let's say, images are read and written. So sometimes Napari and other image viewers will have a particular way of reading in files, and you can lead to scenarios where Napari might identify an image as, let's say, sort of the depth is being read before the channels, whereas what we're doing on the Nextflow side of things could end up reading that the other way around. By having a central utilities package, we're able to sort of standardize and ensure consistency with how things are read across the entirety of AI on Demand. And there's some other useful things within the utilities there, which I can go over. But the point of this is not to tell you how all the sort of repositories interrelate. It's also to point out that we have separated functionality. So for a particular project that you're doing, you may not actually, let's say, even be using sort of some of these AI models. You might not need the rest of AI on demand, but within our utilities package, we have this RLE, this run length encoding. It's a sort of customized format for basically saving segmentation masks in a very compressed way. You may find that that is just useful for a particular project, so then all you need is our utilities package, and you don't need the rest of the framework. But it all stitches together and sort of uses each other quite nicely in general. So there's quite a bit to sort of AI on demand, but I thought I'd just highlight a few sort of features of it that I think are of particular interest to this community. And sort of the reproducibility that I mentioned before. So our Napari plugin automatically is generating the configuration for you. And as part of this, it creates a unique hash based on the parameters. And so we have a little pop-up window in our Napari plugin that you can see on the right-hand side here that just shows all of the parameters for the particular of everything that you've basically selected sort of within the interface. And then there's a unique hash that's created from this. This hash is then used sort of in the file names of your sort of configuration. So this helps with sort of the traceability of what created what results, and also having that configuration file to then later reproduce the results sort of as needed. And as I mentioned as well, sort of Nextflow stores those results temporarily within its own sort of cache with those hashes as well. So this really helps with reproducibility. And in our Nextflow pipeline, having every processor model in its own environment also really helps with that. And at the moment, as I said, this is defined by conda environments, but in the future, we look to really sort of move properly to using containers for this. This is already sort of work beginning on this, but is something that we will move to as it's sort of really important, as you'll know if you saw sort of Martin's previous webinar on containers. So AI on Demand also has a central cache. So a cache is really just a sort of a temporary sort of storage, a temporary folder that exists basically. What we use this centralized cache for is for storing sort of models themselves. So we call them sort of checkpoint files. It's for storing the segmentation masks that are output by AI on Demand, storing all of the sort of the conda environments, although I will say this is configurable by the Nextflow profile. So at the CRIC, what we actually have is all of the conda environments exist in one place on our HPC, so that everyone is then just using those environments. So there's no sort of repetition of environments and wasted storage. The cache also stores the sort of the run configurations, which is this that I showed on the right-hand side. But also project configurations. So this was something that sort of some of our users requested. There was a great suggestion because I think it's a very useful thing, and is also something Joost in our team has worked on other projects of essentially having a config that defines everything that you've like clicked and selected within the Napari user interface. This is useful for sort of traceability, but it's also useful in that you can then load and switch between projects. So obviously you can imagine with with sort of different models when there's lots of parameters, you don't want to be sort of clicking and changing things. And so the project config, you can just switch between projects and it will repopulate, re-click the entire interface for you, which can be helpful. There are advantages, however, when sort of centralizing this AI on demand cache between multiple users. So, as I mentioned before, previous results can be reloaded. So, if someone's used the same model, data, parameters, everything, then it can load results from that previous run as long as the cache hasn't been deleted. Uh, Although this is more useful with multiple people, I found it can also be useful for just individuals who may have run something a month ago that they forgot that they ran, and so it will then just reload the previous results rather than wasting compute. The models and environments are reused, but I think something that's also really key is that we can also have private sort of internal models that exist in this cache. So within AI on Demand, when you define a model within the schema where it exists, you can define it by a file path. So it means that only people that can see that file path can actually use that model. And so let's say a particular lab is working on a training a model, but it's not yet ready for sort of publication and release. Everyone in the lab can still use that model if it exists within this cache. So that can be sort of useful. And then in the future, when we move to sort of fine tuning, uh, initially, again, those fine-tuned models are likely to be sort of more private before they're made public. And those can also exist in the cache, so at least a subset of people can initially use that model. Obviously, you can scale this up so that the cache exists at like an institute level, in which case then you get even more sort of efficiency gains by not duplicating either environments or compute. For a bit more detail, there's a link to our sort of documentation at the bottom where I go over some of the caching and the benefits. Um, We've also really wanted AI on Demand to be quite extensible, and so adding new models should be reasonably painless. We've tried to have it as a sort of a lightweight schema, and something I'll go into later as well is that the sort of the Napari interface writes itself as we add models, uh, reducing the maintenance burden on us. All someone would need to do is just update the registry version, but I'll sort of show a little bit how that works later. Also, by having the sort of the decentralized utilities that work across sort of front ends and back end, it means that support for particular metadata or perhaps like new file formats, we only have to change it in the utilities in one place, and then that benefit sort of propagates to everything else. This also extends to adding more pre-processing functions. Or adjusting the way that we're doing the sort of the parallel processing over images and making that more efficient. Just having one place to do that means it's quite easy to extend for us, but then it's also quite easy for others to then use within their own projects if they only need that particular part of it. And also hopefully making it easier for other people to work on too. And as I mentioned, so with the workflows, Nextflow is inherently modular. And so people can take our existing processes, either add new ones or just sort of mix and match them and adapt to different contexts to try and sort of be as widely useful as possible. And as I sort of mentioned a few times throughout, it's really, really important to avoid wasted compute. So on the storage side, that sort of custom run length encoding format I mentioned, in general, this makes the file sizes smaller by roughly sort of 100 to 1,000 times versus a sort of as compressed as possible TIFF file, which has been sort of very useful, particularly as within AI on Demand, you can generate quite a lot of results quite easily. This dynamic sort of parallelization means you're trying to keep your compute efficiency as high as possible, so we're not sort of wasting time or wasting resources and electricity and all these things. The dynamic resource requests that I mentioned, this helps with that sort of making our compute utilization and efficiency as high as possible. And so I've given just a lot of example there on the right of what it actually looks like on the Nextflow side of things. So basically what this is saying is that the amount of memory that's being requested is either sort of 5 GB or 1.1 times the file size of all of our input masks, whichever is greater. And so this means we're really sort of scaling what we're requesting based on the input. And as I mentioned as well, with the centralized cache of sort of reloading things there really avoids sort of people submitting the same jobs over and over again, which I think is a little surprisingly common sometimes. So looking at AI on Demand as a platform, and sort of some of the things that we've done to try and make it as easily extensible as possible. One example here is on the pre-processing side. So in our utilities package, we have defined the pre-processing functions. These are all defined in a very similar way under a pre-process class within Python. And what this enables us is this automatic user interface generation. And I will say, although this is done in Napari, the way that we've written the plugins within Napari is using Qt, which is a sort of generic graphical user interface software. So the same sort of code and things could be sort of separated out to create a standalone interface outside of Napari, so as portable as possible. But it means that the Napari plugin at runtime, when you load it, it creates these boxes that you see here on the right using the information from our utilities package, which is, I think, it's useful for me. It means I don't have to write sort of user interface code, which isn't always the easiest. And it means that when anyone really, would add a new pre-processed subclass, that then the interface for everyone would then update and add the additional box for that new pre-processing function. And we have some functionality on the Napari side as well to be able to run these pre-processing functions on your data. So you can kind of preview what the pre-processing is doing before you then send off the actual job, the actual sort of Nextflow pipeline itself. So having that preview can be quite useful. And we've replicated this functionality to the model side of things as well. So in the middle, there's a intentionally unreadable screenshot of a part of the segment anything to schema within our sort of model registry. And that part there is defining the different input parameters for the segment anything, both what the name of the parameter is, but a sensible default value and a little tooltip explaining sort of what it does. And then the same thing is that on the Napari side, at runtime, as you select a model, the parameters get populated from this registry. So once again, we have a single source of truth. So if new interfaces were to be written, we could follow a similar pattern. And if we add new models, this stuff gets written automatically. We also use this information then on the Nextflow pipeline side of things so that we then automatically pull, let's say, the URL of where the model needs to be downloaded from, if it needs to be downloaded. And some stuff that's in development can be quite useful as well, is sort of the size of the model. And this we can then actually utilize to identify whether you actually have a GPU big enough to run the model that you've selected. And I think it's quite good to have this information up front so that we can, a little flag or warning can come up or some kind of error basically saying you can't run this model given your resources. So these errors happen before we submit jobs, before we waste any sort of compute or time. And we can extend the same thing to the axes of basically what a model can run on. Because there's been times where someone will, let's say, have a multi-channel image from sort of light microscopy, and then they're trying to run a model that's been trained on sort of single-channel electron microscopy images. And that's naturally not going to work, but it's much better to get that information and that error up front. And we can have that by having this centralized information within the registry. So in the model registry itself, we have a bit of a hierarchy with how sort of models are defined. And we've done this between sort of having a model family, which is sort of an overarching name or a group of models, and then the specific model versions themselves. So by way of example, something like Empanada has a few models underneath it, and that would be a sort of a model family. On the light microscopy side, something like CellPose is quite popular. That's a model family. And then sort of segment anything as a group of models as well. And then specific model versions. So these are then the actual specific models with files, things like MitoNet for Empanada or Cyto3 for CellPose, are then sort of model versions defined within the registry. And then each model is also has a task associated with it. So they're meant to be more a sort of a user-friendly signal for what that model is actually used for. And it also helps us with sort of categorizing models and dynamically serving up the selections to the users, which you can see on the sort of Napari plugin. So although this may be sort of more useful for sort of model developers, I think increasingly there's going to be a case of people definitely on the fine-tuning side, but people also maybe just sort of creating their own models, particularly sort of maybe more model versions than entire new sort of model families. So it's a sort of a rough kind of flowchart of that process. In that if you just have a new model version, it should generally be really easy to add a new model to AI on Demand. Sometimes you might need to update the sort of Python script for that specific model, which I'll sort of show the setup of that later. But in general, all it really requires is just updating the schema in the registry, so adding an extra block for this new model version. And then that's it. Because of all of the things I mentioned before, everything else will sort of automatically update according to that. If this new model version represents a new task that's like a particular organelle or something like that that's not in our existing task list, then you also need to update that in the registry. Adding a new model family is a bit more involved. So this you would then need to create the new Python script for that model family within the pipeline. You'd need to add a sort of conda environment for that model as well, and then add a new schema to the registry. Again, this is something that I envision some people will be able to do sort of autonomously, but I do expect it to be sort of done in collaboration with us if we're not the ones doing it directly. So the actual model registry schema itself, as I said, we tried to make it very lightweight, and it just defines a few things of the particular model versions, their locations. So whether it's defined by URL, as I mentioned before, being sort of public for everyone, or if it's defined by a file path, then it's only people that can actually read that file path that can use it. Any sort of model configuration, and then, as I said, sort of the parameters for the model with default values, tooltips, and then other associated metadata. So any publications and the authors associated with it, the repository for that model, that sort of information. If you saw Kimberly's webinar, she spoke a little bit about sort of GitHub Actions and things. We have some of that set up for sort of automatic validation testing so that we know if a schema is being added or modified, then it's automatically tested so that we know it can fit in with the rest of AI on Demand and be read to generate the interface and all those sorts of things. We have a future aim of simplifying this process further by perhaps allowing for users to add models to the registry via an actual sort of graphical user interface itself. So whether that's through Napari or through something else. And I think this will be particularly key when it comes to sort of fine-tuning side of things because people will be creating models at a much higher pace. Because we have tried to make a lightweight schema, the ability to expand the models that are available now on demand should be pretty simple. And really, AI on Demand provides a platform to do efficient compute over arbitrary models. And so we can more easily integrate sort of great model collections like the Bioimage.io model zoo. So through representing that as one model family, we could then integrate the entirety of those models within the zoo. But the onus really is on us for the schema. So again, I expect this to be sort of within collaboration. But really, sort of the AI on Demand team is working on the sort of the framework for all of these things. We're not necessarily focused on adding individual models. So at the moment, this process is very much by request. Because we can't necessarily foresee what would be the best model for sort of people's specific projects. But it's always that thing of sort of get in touch if there's a model that you want that's not available, and then we can add it. So I wanted to go through in a little bit of detail the actual Nextflow pipeline itself. Again, the input parameters to the pipeline could be done by the user, but using the Napari plugin, this will sort of create it automatically for you, or if we had other backends, they would then do the same thing. But there's one sort of central input for the parameters there. If you were to run the Nextflow pipeline sort of by yourself rather than letting sort of Napari handle it, then this is the kind of command that you would put into the terminal of basically just running our pipeline and then defining the configuration file, the params file here. The first step is sort of setting up the model. So this is downloading the model if it doesn't already exist in your cache and making sure that everything is ready for then sort of actually running the model itself. Then there's a pre-processing step. If you have selected pre-processing parameters, then those things will be done here. Um, is put a process solutions say values of sort of downsampling or histogram equalization, because you can then get different results from your AI model itself. And so when you have multiple sets, this will actually then run that data with the different sets through the pipeline itself. So you can end up with essentially running like multiples of the pipeline through one run, which can be useful. And then we have the step that really enables the sort of parallelization that we're doing of sort of splitting the image into sort of substacks or sort of sub-volumes to improve that sort of parallelization. So a very small example here, if we split the image into a sort of 2 by 2, this would represent essentially 4 GPU jobs being submitted to the cluster if you were running it on a cluster. And there's also some parameterized overlap here that can be done in different dimensions, which can be quite useful for ensuring that things that are on the boundary of a substack are segmented properly so you have a little bit of overlap so that the model can do a better job. In a sort of more realistic example on a sort of larger image, what this can mean is that the sub-volumes themselves are automatically split by sort of a reasonable size, which will sort of depend on the available resources of wherever you're running this. And this example in a previous version of AI OnDemand, for this input data set with those dimensions led to 117 jobs being submitted. And the general philosophy we take is that each individual job should run fairly quickly. For actually running the model itself, again, thinking about making things as extensible as possible, we have a single process where the model themselves, so the environment and the script that we're running is parameterized based on the input model. So we have different Conda environments here. Generic should be the most useful across different institutions and sort of compute environments. We also have a set of Conda environments that are specifically, we know they work well with the GPUs on our cluster. But we can sort of customize that, and different institutes can have their own different environments and things. But as I said, long term, we will be moving to containers. Same thing of sort of one Python script per model family, where that defines how you actually run the model. But there is a common input and output that we have utilities around running each of these models. So what someone needs to do is basically fill in the middle bit of how to run the model. And then with all those sort of parallel outputs, we then need to combine everything at the end. Aggregate overlapping masks. If that was done, at the moment we have a parameterized voting mechanism, but we're looking at sort of more sophisticated approaches. And for very dense masks, for something like segment anything, there's an optional sort of intersection over union threshold for how to merge things over 3D. The next big step, though, is on sort of fine-tuning any model. So a modification of sort of the overview schematic before is that now the back end is training, fine-tuning a model to then produce an output, which is the new model checkpoint, the updated weights itself. And I really see this as part of a sort of a cycle of iterative model improvement. So obviously the starting point is you need some input ground truth for your data to fine tune the model with. And this can come from sort of manual annotations, using an existing AI on-demand model as like a base of masks, maybe some other plugin in the program that you're using, or some sort of promptable model like segment anything. But really I expect it to be some mixture of the above to get sort of the kind of ground truth that you need to put into a model. And then through sort of the model registry and that sort of centralized cache, these you can then get instant sort of private use of your fine-tuned models. And we also have some built-in evaluation tools to help sort of tighten that loop. So you can fine-tune a model, evaluate it on some held out data, and maybe sort of fine-tune again if the performance isn't good enough. And then when you're happy, then run the model through our existing pipeline over all of your data. But finally, just sort of looking sort of forward, everything I've spoken about so far is on sort of segmentation, but there's really nothing in AI on demand that's sort of beholden to that or sort of constrained to it, because really those individual Python scripts of how a model is running All it really does is take the model checkpoint, the file, a configuration, some data, and produces an output. The nature of that output just changes depending on what you're trying to do. This would require a change in the combination step because instead of combining sort of segmentation masks, we might be combining bounding boxes for object detection, or if we're doing classification, about combining a label instead. But because of the Nextflow process, that step can just be sort of modified. But we can also reuse some of our existing processes like pre-processing or sort of splitting to get that sort of parallelization of things as well. AI on really has been designed, I think, I hope, to be contributable to from the community. We have on our documentation a future development bit, which is kind of showing our roadmap, which I'll just sort of summarize as sort of better NGFF, so next generation file format support. So for information on that, so Chris gave a really nice webinar on the OMISR stuff, and we could better utilize some of the features in there to make it to make OnDemand work better with this sort of the very, very large OMISR data that's coming out. As I mentioned, the fine-tuning workflow, we could also have better integration of sort of annotation tools to make generating you that ground truth for fine-tuning easier. Again, there's the option to move sort of beyond segmentation, but really also sort of wider accessibility. So if people really, really love Fiji and they want a plugin for Fiji, then we can develop that or in combination, and then this can then sort of feed into the on-demand framework. And I think it really helps. There is ever more models being sort of released to do different things, and it's really impossible to keep up. But by having a central place that people can add models and run those models on, I think it really helps with sort of us as the community in terms of sort of keeping up with these papers. And having expanding the tools that we've got for sort of post-processing and evaluation can really help with creating this sort of end-to-end platform. And finally, I thought I would just say if we're really sort of looking more towards the future, then being able to use AI on-demand through sort of large language models, I think would be very, very useful. AI on-demand, fortunately, in its setup has a lot of sort of queryable inputs. So you can query the model registry to know what models are available, what parameters they've got, and all this sorts of things. And through something called an MCP server, we can equip an LLM with that information that we've already got from the model registry, from our utilities, from our pipeline, so that we can then create the sort of the input configuration to run the pipeline in a defined way, so avoiding hallucination because we've given it all the information about what's required for AI on demand. And we can even go further and equip knowledge. So a small change to the model schema, providing a short description of sort of what data that model was trained on, and therefore what data that model is most useful for, could then add a little bit of guidance maybe of what model within AI on demand should be selected. And if possible as well, sort of what parameters might make more sense for this particular model. This is something I've started to look at, but is very much looking towards the future. But I think it would further improve that sort of accessibility of using AI on demand, but still backed up by sort of some of the reproducibility that we're really trying to ensure is there. So I just thought I'd sort of finish up by just sort of thanking sort of the people that have worked with me to develop sort of AI on demand within the software engineering and AI STP. The electron microscopy STP at the CRIC has been really useful with sort of the feature requests and sort of testing this out and helping us. And obviously people in HPC as well have been very helpful with getting us to run these things. On the right-hand side there, I've got links to the different sort of repositories involved if you're interested. But yeah, thank you for your attention.
Thank you, Cameron. That was an excellent talk. I thought considering the complexity of the framework that you've built, you put that across really, really clearly. So thank you.
Thank you.
We now have about 10 minutes for questions. So if anyone would like to ask Cameron anything about AI on demand, then please add your questions to the Q&A tab and I will read them out for Cameron. But in the meantime, I have a few questions of my own. I thought it was incredibly thought-provoking, so I have a very long list of questions to ask you. I think the first question that perhaps is front of mind for our audience, which will be a combination of people with different specialisms. Some of them may be at the crick and some of them will be beyond. And so I thought, considering the diversity of our audience, what would be the process that different people would need to take in order to get started with AI on demand?
Sure. So I would say we have documentation. Might be easier actually if I just quickly share screen. This documentation. So we've got here. It's not 100% complete. I would say there's always better documentation you can have, but there is a page on sort of getting started, which I tried to separate between. Obviously, if you're at the crick, there's a certain it's easier to do, but if you're working sort of locally, or if you have your own sort of HPC at your institute, then there's a sort of a fuller guide on how to get on-demand set up. This has been run, it's been deployed at a couple of different institutions, and I think sort of that guide is a good starting point. But always sort of reach out to me, sort of contact us as well. In a lot of cases, it depends on sort of the setup that you want to have. So at the moment, what we've got is something called Open On Demand at the Crick, which is a sort of think of it as a sort of virtual desktop that's connected directly to the HPC. So in that setup, people can then sort of run Napari directly connected onto the HPC and then work directly with Napari there and submitting jobs to the cluster. So that's sort of one route to go, but you can also just run the pipeline by itself if you don't necessarily want to use Napari or something like that. But I will say something we're also working on is the ability to essentially have Napari live in a completely different place and sort of do the compute remotely over SSH. So you could have Napari running on your laptop, but it's sending the jobs to the HPC to run and then returning the results to you back to your laptop. That piece of work is pretty much done and will be released in the next version of AI on Demand. But yeah, I'd say look at the documentation as a first port of call, but also feel free to contact us.
Great. It's reassuring to know that you're happy for people to contact you if they've got any questions. With that in mind as well, are there particular institutional stakeholders that teams normally need to rope into these conversations?
Yeah, I think having HPC for your institute there earlier in the conversation could be quite useful. As well on the documentation, I've put a little guide in there about sort of tuning the pipeline because I mentioned a few times, right, about sort of efficient compute and things like that. Some of that it's inevitably institute specific. So I've put some sort of loose heuristics there of what you need to do. But I think having them early in the conversation can be useful to know if containers really is an option, if Conda is a no-go, that kind of thing, so that you understand the feasibility of deploying this straight away. And although we try to be efficient with the compute, if you do throw a lot of data with a lot of different sort of pre-processing options and things at AI on Demand, it will naturally run quite a lot of jobs. So depending on what resources you have available, it might be good to have that conversation as well.
Yeah, that's really helpful advice. Another question, perhaps on more of the sciencey side of things.
Yeah.
So I was interested in what you were saying towards the very end of your talk about including an MCP server and LLM
Mm.
functionality in
Hmm.
order to help guide people in their selection of an appropriate model. And that sounds really intriguing. And I can see that that sort of functionality becoming increasingly important as we move forward in this space as more models are generated. I wondered if you could speak to that subject a little bit more.
Sure. I think I take a fairly sort of conservative approach with it. So as I said, sort of using a lot of what already exists in AI on Demand to just inform an LLM of how to configure AI on Demand and what's possible. Conservative in a way of an LLM could very much suggest to you of like, oh, given your scientific problem or given your data, this model is the best one and these parameters are the best way to go. It doesn't necessarily know that. And so that's why it's about us putting as much of the information in as possible of of within sort of the model schema and things of some high level guides and heuristics of hints of where this kind of thing might be most useful, but not necessarily sort of dictating that for this scenario you use this model. And so I think sort of being a bit more conservative with that and avoid these issues of sort of hallucination, sort of misleading information, that kind of thing as much as possible. I think is this sort of approach that we'll take to it.
Yeah.
Um, yeah, good.
Yeah, so something I wondered was whether you could see a possibility, whether it would be technically feasible to have a user upload a small amount of their data with a ground truth annotation and then have the system recommend which model would be most appropriate. Is that something that would be
It's
feasible?
it's simultaneously the bit that would be most useful and the bit that I'm most worried about.
Okay.
Um, I've seen some examples of where even just giving an image to an LLM, it was able to identify, the channels, what antibody staining was used in light microscopy, this kind of thing. So it can do a good job sometimes. Um, and that would be very useful. I would just want to make sure that we have a good understanding of that ourselves. And so embedding some of that information within the sort of model schema. And this is also where I would really like to have that dialogue with the model developers. They know their models best. They know the biases and what data that model was trained on best. And therefore, the scenarios that that model is most appropriate for. And that's the kind of information that I'd want to capture to put into the schema that can then inform the LLM.
hmm hmm Perhaps on a related note and a little bit more broadly, do you see us converging to a point in the future where we would ever have a foundation model in this space?
It's interesting, right? Because a foundation model um, will have sort of fundamentally good generalization capabilities across, let's say, sort of within electron microscopy. I'd say MitoNet already does a pretty good job across lots of different things. But there's always going to be edge cases, and particularly when institutes are working on, never before seen image modalities or brand new microscopes, new techniques, or new samples themselves under study, it's always going to be outside of the training data and the ability to generalize for a foundation model. But that's where I see that it actually may do an okay starting job. And that's where we'll move more to a paradigm of fine-tuning foundation models rather than just training new ones.
Yeah, yeah, I think that there will be a really interesting um, question space that emerges around, well, what's good enough for my specific
Yeah,
research case and the questions that I want to address. I
yeah.
think with that question, that very broad question, we will leave it there. We've got 2 minutes left, so I'll just wrap up and say thank you again, Cameron, for your talk.
Thank you.
And I just wanted to flag that the next talk that we'll be having will be in September, September the 15th. You can find information on our CCP-volumeEM website. It will be from Kedar. He'll be speaking about empanada, so it's a really nice follow-up from Cameron's talk today. And also just to draw attention to our YouTube channel, we have been uploading the talks from our show and tell series onto our YouTube channel, so you'll be able to find some of the talks that Cameron mentioned in his presentation there about containers and our presentation from Kimberly Meakin. You can catch up there if you're interested. So thank you all again for joining us today, and see you next time. See you in September. Bye bye.